afternoon, welcome back to our chemical equilibrium acid basis, and today we'll see the buffers. We already seen the how the common hydrolysis and all these things. What is buffer and why buffers are important, and how the pH is maintained. Say buffers are nothing but the solutions which maintains the pH. Otherwise pH will vary for the secondary standards and all with time, with the temperature, with the small fluctuations and all. Buffers means its pH will not alter by adding a small amount of acid or alkali, or with a time of some up to some 5-6 days and all these things. With the small means there will not be a fluctuations because of the small fluctuations. It will not fluctuate with the temperature. It will not fluctuate with the small temperatures or small addition of acids or small. They are called buffers. So what is how the buffers are required? Why it is required? Why required is the pH meter is the normally used for measuring the pH of the dilute solutions. The pH meter will be calibrated with the buffers. Buffer 4.27 and 8.2 or 8.3, like this buffers will be. pH there is no scale. pH means there is no units. Scale means units. So it will be a numerical value. So all the pH meters will be measured by the normally the standard buffers. The standard buffers, one is a weak means acidic side buffer, alkali side buffer, and neutral buffer. So buffer is nothing but it is a solution where whose pH will not alter with the small addition of acid or alkali or temperature change and all. Now the how to prepare a buffer. Buffer, if it is a weak acid, weak buffer means acidic buffer. It is a weak acid, combination of weak acid plus salt of weak acid salt means strong base. Salt of strong base. Example is acetic acid. It is in a weak acid plus its conjugate base is acetic sodium acetate. That means it has come from sodium hydroxide and acetic acid. It is a salt. Has come from the conjugate of this. That means sodium acetate. Its pH will be stable at 4.2 once it is prepared for some 5-6 days, and small additions also it doesn't alter its pH. Similarly, another this is a acidic buffer. Another one is a alkali buffer, means basic buffer. That means you have to take here now the weak base and the salt of its conjugate. That means from acid, strong acid, salt. That means ammonia, a mixture of ammonium chloride. Chloride has come from the ammonia and ammonium hydrochloric acid. Salt is ammonium chloride. Ammonium chloride is the conjugate base of this one. So this is a base, weak base plus salt of its conjugate to acid. That is whose pH will be the basic pH. So 7 neutral preparation is very easy and all. So buffers will be used for the mainly calibration for the pH meter, and the pH meter used for the measuring the pH, and where the normally the medical field very important for the blood normal will be in the alkaline, the ranges, small ranges, and the urine pH and all these things. So small examples of what is the relation and how to prepare this thing we'll see. As first one we'll take the weak acid is HEA I am taking, plus that is mixed with water in equilibrium with means H3O plus and plus A minus. It's if I am taking the Ka H3O plus A minus by water I need not to take HA, and rearranging this and rearranging what will happen. H3O plus if I want for the pH this thing, and equal to Ka into HA by Ka by A minus. This will be this thing. That means this will can be written as a minus log pH. pH is equal to minus log H plus concentration. So pH, if I am writing, pH is equal to pKa, Ka, and plus log salt by weak acid. Similarly, pOH also I can write for this other one where we want is pKb plus log B by Hb, like this we can write. So we can prepare also like this. So that is about the buffers, and the buffers are the very much required for the preparation of this. So, and we know that pOH plus or pH equal to Kw. We know from this also we can write how the relations of pKe and pKb are. Earlier we have left the one small problem. That problem is what is the pH of the 10 to the power of minus 8 molar HCl. This is immediately people will say actually 8 and all these things. So remember this will be so if it is asked in interviews, then immediately you have to say it should be the acidic less than 7, because it is HCl added to neutral water, not the anything else. So if it is an interview question, if it is limited to the one line this thing and or how much value, there is a simple calculation, easy calculation, or if it is a lengthy the question type like this, both we will see the problems. If it is an interview, that immediately it should be said this is acidic, because it should be neutral, you added the acid, whatever may be the amount. For immediate for the tick mark answers and all, it can be like this. Already water is having 10 to the power of minus 7, because it is the diluted solution, H plus ions. And now you added the HCl, it is dissociated into H plus plus Cl minus. That means 10 to the power of minus 8 H plus ions is already added to the again to water. This means total the H plus ions concentration is equal to 10 to the power of minus 8 plus 10 to the power of minus 8. For immediate for 1 minute answer for this thing. What is take out the 10 to the power of H plus ions concentration if you are taking, this is 1 plus 0.1. Nothing but 10 to the power of minus 7 into 1.1. This is H plus ions concentration. Then the log will be 7 minus log 1.1. For the easy miss, if it is a rough value answer and all, for the tick mark answers and all, it will be 1.1 will be normally some 0.4, so 0.04, so it will be 6.96. So like that it can be easily. Otherwise, if it is a big question and all these things, how to write the same question answers and this thing, H plus concentration is same, you have to write like this. Then don't take the resistance. This is the 10 to the power of minus 8 is the added the H plus plus X is originally there. Don't take it the 10 to the power of minus 7, and the OH is also there as X. Kw equal to 10 to the power of minus 14. No, H plus concentration is 10 to the power of minus 8. Originally already there is the X, and X is the originally the OH, total equal to 10 to the power of minus 14. Now X we will find out, and then we have from this we can solve, but it is a lengthy, but no problem. X square plus 10 to the power of minus 8x minus 10 to the power of minus 14 equal to 0, a quadratic equation which can be easily solved. So if you solving this x equal to minus b plus or minus root of b square minus 4ac by 2a equation, if you are solving in the quadratic equation, where is a equal to 1, b equal to 10 to the power of minus 8 and c equal to 10 to the power of minus 14, if you solve the x equal to will come as a x value will be you are getting, and from that is the x is nothing but OH concentration. From that to see exactly calculations of the x, then you will get the value of the 9.5 into 10 to the power of minus 8, you will get x value. That means that is nothing but OH value. So pH equal to, from this you will get 6.98. So exact value calculation, there will be a small difference directly if you are doing, but nothing wrong if you are giving also this one, because values will be very close. If it is a short answer, directly you can take. If it is very lengthy, you solve the quadratic equation and all these things. Then some more things we will see, how the effect of the buffers will be affecting the solubility. So what is the solubility and what is the sparingly soluble, moderately soluble, totally soluble, and what is the solubility effect, common ion effect. And then how some more examples of the problems we will see tomorrow. Thank you.